Welcome to A-Level and AP Physics. In today's lesson, we will discuss paper 5-1 from October-November 2022. In this lesson, we will discuss question 1 in detail. I will also teach you how to approach question 1 in a nice way, means in a proper way. I will explain you one systematic approach. And for question 2, we will also discuss some good techniques, means smart ways to answer question 2 as well. Let's study together. Let's improve together. In today's lesson, we are talking about October-November 2022 paper 5-1. Total time for this exam is 1 hour and 15 minutes and total mark for this paper is 30. And you need to answer all questions in this paper. Means there are only 2 questions and you need to answer both of them. For question number 1, it is very important that you read question carefully. If you don't understand question first time, read again and try to highlight the key points given to you in the question. And this will help you to design your experiment in a proper way. If you look at this question, for this question it is given to you is a thin copper sheet is suspended from a small hole near the top of the sheet, placed in a magnetic field. So it is given to you that it is placed in the magnetic field. So it means you have to apply magnetic field in this case. So it has to be in the magnetic field. Very important point. So when you draw your figure, so you have to consider magnetic field. And it is also given to you there is a hole at the top of this plate. So from here we can pass a rod, so we can hang this sheet. And it is given to you the sheet has area capital A and the thickness is T. The sheet is displaced from its equilibrium position through a horizontal distance S0. So very important, it is given to you that it is displaced from equilibrium like this. So this one is the sheet, it is in the magnetic field and we displace this one from equilibrium. So initial value of displacement is given, that is S0. Then release so that it oscillates perpendicular to direction of the magnetic field. The horizontal distance S of the sheet from its equilibrium position is measured after 5 complete oscillations. So this is also very important point. When S is measured, it is measured after 5 complete oscillations. It is suggested that S is related to A by the relationship. So this equation is very important. So you have to underline this one. It is also given to you B is the magnetic flux density and K is a constant. B is the magnetic flux density. We have to plan an experiment to test relationship between S and A. Draw a diagram showing the arrangement of your equipment. Explain how the result could be used to determine a value for K. Question is asking you to draw a diagram. It means there will be 1 mark for the diagram. So if you read question 1 time, so in this case you can see if we read this question, it is given to us very clear that we have a plate that is inside a magnetic field and the plate is oscillating in the magnetic field. So this is the main idea, and in this case we have to keep initial displacement, horizontal displacement constant S0. If we have understanding of these things, now we can start talking about designing experiment, I mean how we will design experiment. In designing experiment, you have to consider these points. You can use headings like that. You can say defining the problem. So the first step will be defining the problem. So this is defining the problem. In defining the problem, you need to understand which variable is independent variable and which one is dependent. So we will be writing here independent and we will write down here dependent. So this is what you need to write down for defining the problem, independent. And control variables. The variables you have to keep constant. So simply we can say control. So independent variables. So we have to design experiment for S and A. So now you need to understand A is the area of the plate and S is the distance after 5 complete oscillations. So which one you can change? So in this case, area of the plate we will change. So due to change in area of the plate, S will change. So it means area of the plate is over independent variable. So this one is independent. And dependent variable in this case will be S. So you can write on here S is dependent variable. So how about control variables? So if you look at this equation, you can see, let me rewrite this one. S is equal to S0 e to the power of minus AB. We have K times T. And so in this case, This one has to be constant. Initial horizontal displacement has to be constant. So this is one control variable. So we can write on this as one control variable. Area we are changing. So this is our independent variable. B has to be constant because this is the magnetic flux density. We have to keep this one constant. K is a constant. We don't know what is K. And T is the thickness of the plate. This also has to be constant. So in this case, simply we can say our control variables are S0, and B and T. So these are control variables. So if you have written these points until now, you will get 1 mark. If you have written these two, you will get 1 mark. You will get 1 mark for writing this one, and you will get 1 mark for writing these two. If you have written these two are constant, you will also get 1 mark. So you will get 1 mark here. And if you have written S0 also, you have to keep constant, you will get another mark. So you will get 3 marks if you have written only independent variable, dependent variable, and control variables. And these are very easy to find. You just look at the equation and you can figure out these variables. And the next step is how we can sketch a figure. That is very important point. So in this case, we can simply see that we have a plate that is inside the magnetic field, and this one is oscillating, and this plate has to be suspended from a point. In this case, hole is given to you, so we can pass a rod through the hole, and this has to be oscillating inside an external magnetic field. And initial displacement always you have to keep constant, so it will be oscillating like that, and after 5 complete oscillations you will find value of S. So I hope you got the idea. Now you also need to understand, in order to find, for example, value of B, what kind of instrument we have to use. For B, this is magnetic flux density. Magnetic flux density, you have to use Hall probe. Very important instrument. For B, you have to use Hall probe. So you can also sketch in your figure Hall probe. So these points. If you have understanding of these points now, we can go to next page and we can draw the figure. If you go to the next page, you can see I have drawn the figure here. So we can save some time and quickly we can go through these points. So let me clear this part because we have done this part. So let me just clear this. Now in this case, you can see how we have drawn this figure. You can see this one is the sheet, means this is the plate, and here we have drawn this is the Hall probe. You have to label all these instruments, and here we have this is retort stand, and here is a clamp. In the clamp we have rod. Clamp is holding the rod like this, and the rod is passing through the sheet. So this sheet will be oscillating like this in the magnetic field. So this one is the magnetic field. But we can also add one extra, meter rule. So with the help of meter rule, we can find out value of horizontal distance. So that will be easy for us to find out initial horizontal distance. So we can add 1 meter rule here. So this is the meter rule. So we can add meter rule here. So with the help of this meter rule, we can find out initial horizontal displacement, and also we can find out displacement after 5 oscillations. But that you cannot find. For that purpose, we will be using another instrument. But with the help of this one, we can find out initial value of S0. So that's the reason meter rule is important. So I will just want to draw some lines here. So it will look like a meter rule. So these lines we can do. So this one is the meter rule. With the help of this one, we can keep S0 constant. So this is what you have to do about the figure. We have discussed until now defining the problem. Let's go to the next point. Now we need to talk about methods of data collection. Methods of data collection. Methods of data collection, and this part is very important one. In methods of data collection, we will also talk about additional detail. In method of data collection, we have already discussed independent variable in defining the problem. Now we will just start from there. So we have independent variable, that is A, and we have discussed our dependent variable, that was S, and we have talked about control variables. We have said B, we have said was T, B, T, these are control variables, and also we have said S0, this is our control variable. Now we need to talk about methods of data collection, how we will collect data. And in this case, we have over 2 variables. One is independent independent, one is dependent. So in this case, we will change area of the plate and we will find out value of S. So when A will change, S will change. So this is one thing you have to write down. So you will say change area of the plate and measure value of S for each area. Now the question is that how we can measure area of the plate. So you need to talk about the instrument you will be using. To find area of the plate, we can use meter rule. So you need to talk about instruments here, meter rule. So then you have to say how you will find area. So in this case, area of the plate, we will write down. This will be equal to the length of the plate times width of the plate. So if you write down this one, you will get 1 mark. And 1 mark for the figure, you will also get. And for the S, how we can measure S? S is displacement from equilibrium after 5 complete oscillations. So it's very hard to see. So the best instrument we can use is video camera. So we can say video camera. And whenever we say video camera, you also need to state view frame by frame. Means you will record the video with the help of camera and then you will watch that video frame by frame. So you have to mention view frame by frame. So this point you have to write down. And next thing, we need to talk about B, magnetic flux density. So how we can determine B, magnetic flux density? We have discussed a little bit about this one before. We have said we can use in this case Hall probe. So it's better to say you can write down calibrated Hall probe. So we can say calibrated Hall probe. So that's very important. So let me rewrite this. So you can say calibrated means the instrument. We are just talking about instruments now, nothing else. In defining the problem, we have discussed dependent, independent, and control variables. In methods of data collection, we have discussed a little bit how you will change the area. Means you will be using plates of different area and you will measure value of S. And now we are simply talking about instrument. What kind of instrument we will use and how we will determine a variable. Means the magnitude of a variable. So we can use in this case calibrated Hall probe. Calibrated Hall probe. So this point you can use to measure value of B. You will be using calibrated Hall probe. And when we talk about calibrated Hall probe, always you need to say adjust Hall probe to get maximum value. Adjust means you will adjust the orientation of the Hall probe. For example, this is the magnetic field. First of all, your Hall probe, let's say, is placed like this. So you will adjust Hall probe. So where value of Hall probe is maximum, you will start from there. So you will say adjust Hall probe to get maximum value. Simply you can say that. Adjust Hall probe to get maximum value. So you will start max value, maximum value. For Hall probe, you can talk about this point every time when you mention Hall probe in your questions. Now the next thing, so you will get 1 mark for that. Now the next point we need to understand is for the T. So we will be talking about T now. So how we can measure T? Thickness. So we can first of all, we can talk about the instrument we will be using. So we can use, in this case, micrometer screw gauge. So we can say micrometer screw gauge because the thickness will be smaller than 2.5 centimeter. So you can use micrometer screw gauge. If you write down this one, you will get 1 mark. Micrometer screw gauge. And also now you need to talk about this one, how you can measure thickness in a accurate way using proper method to get accurate value of T. So for that purpose, we will measure thickness at different positions and we will take average. So measure T at different positions and take average. At different position means we have this plate. We will measure thickness here, measure here at this point, then take average. At different positions and take average. So this is how you can improve. You can get means accurate results. So this is the additional detail. It's a very systematic approach. Most of the time, students, they are not clear how to approach. They just start thinking in a random way. But there is a systematic approach approach. This is how you need to follow. Take average. So we can simply say take average. So you see, we just started with the variables, and now we are talking about how to measure variables in data collection and how we can measure in an accurate way. So that is your additional detail. So you will get 1 mark for this one. You will get 1 mark for this one. S naught. If you have mentioned about this one, S naught keep constant, you will get 1 mark. And if you have drawn this meter rule here, because with the help of meter rule, you can keep S naught constant. So every time, for example, this is the plate. I will displace this one by this amount. So here I have meter rule, means let me say here I have meter rule, so I can see the reading from the meter rule. So every time when I change the plate, I will start oscillation with that value, and that value you can see with the meter rule. So if you have drawn this meter rule in the figure, you will get 1 mark for that as well. So you will get 1 mark for that. Extra 1 mark. 1 mark for the figure, 1 mark for drawing this meter rule in your figure, and 1 mark to keep, if you say keep this one constant. So you see, 1 mark if you have said keep this one constant, 1 mark how you will keep this one constant. So that is very important. So T thickness, so this is how you can keep constant. Every time when you take the plate, new plate, you will measure thickness, so it has to be the same. B, how you will measure B, 1 mark for this one. And for S, if you have mentioned about video camera, you will get mark for this one as well. So you see, if I start from here, 1 mark for this one, 1 mark for this, you will get 1 mark here, and you will get 1 mark for this one, 1 mark for this, 1 mark for this, and you will get 1 mark for this one. So how many total marks here we have gained? 1, 2, 3, 4, 5, 6, 7, 8 marks. 8 marks you have got here. 8 marks. And in this case, you can also see we have 8 marks here, and we have got 2 marks before. So it means 10 marks we have got here. 10 marks. Now, if we go to the next part is about method of data analysis. In method of data analysis, you can talk about this equation is given to you. S is equal to S naught e to the power of minus AB times K times T. We have to find value of K because question was asking you how you will determine value of K. So first of all, we can write down this one in linear form. So if you take ln on both sides, you will get ln S. This will be equal to minus AB. We have K, this is T, plus we have ln S naught. Now if we compare this one with straight line equation, you can say Y, this is equal to mx plus c. So in this case, a is our variable, this is our independent variable, so the gradient is equal to this one. So this is the gradient, and this one is our y-intercept. So from here we can say that in this case, m means the gradient. So we have to find k. We can simply say gradient in this case is equal to negative b k t. So we need to determine k. So k from here, simply we can say this is equal to negative gradient. So this is negative gradient divided by bt. If you write on this one, you will get 1 mark. Then if you have written sketch a graph between ln s and a, you will get 1 mark. So you can say sketch a graph between ln s and a. So we have ln s on y-axis, this is y variable, and we have here a, this is on x-axis. So in this case, we will get graph with negative gradient because here is a negative sign, so the gradient is negative, and this is value of ln s naught. So this is our y-intercept. And you also then you have to write down relationship is valid if graph is a straight line with y-intercept that is equal to ln s. You will get another mark. So 1 mark if you have written sketch a graph between these two quantities, another mark if you have written relationship is valid if graph is a straight line with negative gradient and with y-intercept that is equal to this one. You will get another mark. So you will get 1 mark here, 1 mark relationship is valid straight line. Let me write down straight line relationship is valid if it is a straight line with y-intercept. With y-intercept you will get another mark. So you will get 1 mark here. So you can see here in this case we have 2 marks before, then we have 8 marks, and now we have 3 marks here. So we have discussed 13 marks until now. I hope these points are not very difficult. If you simply understand basic instrument, then you can write down step by step these things. So one thing I just want you to realize is that in defining the problem, what you need to do, you need to write down which variable is independent, which variable is dependent, and which variable you have to keep constant. So that you need to write down in defining the problem. And then you need to sketch a figure, and after figure you need to talk about how you will measure those variables. So mean how you will measure independent variable, how you will measure dependent variable, and how you will keep control variables constant. So you have to talk about these things. So that's all what you need to do. This is what we have discussed. And then you need to little bit talk about how to take readings accurately, and that is your additional detail. And then you have to talk about method of data analysis. Mean the equation is given to you. Most of the time you just need to write down in linear form, and then you can talk about gradient and y-intercept. And the last thing is about safety precautions. So let's go to the last point, safety precautions. First, safety precaution means safety considerations. I'll be writing at this point, safety precautions. So let me clean this one. Safety precautions. For safety precautions, or you can say for safety considerations. For safety consideration, you have to look at what kind of risk is there, risk and how to avoid. So we can say what kind of risk and how to avoid, means why and how. So simply we can say risk here, what kind of risk is involved with this experiment, risk, and how to protect yourself, how to protect. Or simply we can say risk is why and how to protect. So these two things you have to write down. For example, in this case we have the sheet, this is hanging. If it fall down, may it hurt your feet, may it injure your feet. So you can say place sandbox, because if this hanging sheet fall down, may it hurt feet. You will get 1 mark. And we can also say in this case, because the thickness of the sheet is very, very small, so it means the edges will be very sharp. So we can wear protective gloves. So in this case, risk is that injure feet. So one thing I can say, it may injure feet. So how you can protect yourself? So just place sandbox under this one. Sandbox. So this is one way you can say. Second way, edges are sharp because the thickness is very small. So we can say edges are sharp. So how we can protect ourselves? Because every time you have to change the plate. So how you can protect? So it's better if you wear gloves. Wear safety gloves. Protective gloves. So simply you can say safety gloves are protective gloves. So this is how you can write on. If you write on these points, you can get 15 marks. My main goal was I wanted you to understand the systematic approach, because question in the exam will be different. If you understand the approach, you understand the steps, you can answer question. And if you're familiar with the instruments, what kind of instruments are there, you can approach. But we have discussed until now 14 points, but I said you will get 15 marks. So let me explain you what is the last point you have to mention. That is about additional details. So what can be, and that one is very important. You can simply say in this case, for example, our independent variable is this one. Independent variable is this one, and this one is dependent variable. For each value of independent variable, you can take true values or more than 2 values of dependent variable, and then you can take average to find value of dependent variable. So simply we can say in this case, for each value of A, or you can say for each plate of certain area, repeat experiment. For each value of A, repeat experiment and take average of S. Take average of S. So journal way, let me explain your journal way. So A, you can say This is your independent variable. So this point you can write down for any experiment. So this is independent and S is dependent. So in the question, whatever is given to you, the A you can replace with independent variable and S you can replace with dependent variable. So this is 1 mark every time in any experiment you can mention. So now we have got 15 marks. I hope this is clear to you. If you still have any question, you can leave your question in the comments. And now we will go to second question. So in the second question, I will explain you how to approach uncertainties, and also I will teach you one general method you can use for any kind of uncertainty when you need to calculate absolute uncertainty. Before we go to question 2, let's go through mark scheme so you can see how we have answer and what mark scheme is expecting for the answer of this question. So if we go through the mark scheme, you can see in the mark scheme, in defining the problem, you have to talk about independent variable, you have to talk about dependent variable. If you have written this one, you will get 1 mark. And if you have said keep d constant, you will get another mark. So you will get 2 marks for defining the problem. And then this is about figure. So if you have drawn figure, you will get 1 mark. In the figure, they are expecting pin passing through the hole, supported by a stand, sheet able to oscillate freely, at least one label from copper sheet, hole, clamp, stand, rod, and pin. So we have done all these things. So if you have done this one, you will get 1 mark for the figure. And next one, drawn clamp meter rule parallel to direction of oscillations by I to measure S. Means S naught. So we have also done that one. We have drawn meter rule. So 1 mark for this one. So in this case, 4 marks you will get. And here is the next mark. Use meter rule to measure A. So you will get 1 mark. And if you have written also area is equal to length times the width, you will get 1 mark. Means 1 mark is combined for this one. And 1 mark if you have written about thickness, use micrometer, you will get 1. So in this case, you can see there are 4 marks to 6 marks. So you will get 6 marks. 4 marks for method of data collection and 2 marks for defining the problem. And next part, method of data analysis. For method of data analysis, you have to write down plot a graph of ln S against A. We have done this part. Relationship is valid if a straight line with y-intercept is produced. And if you have also written K is equal to this, you will get 3 marks for this. I always advise it is better to sketch the graph. So you can also sketch graph like that. So ln S is here and this one is A, and you can draw here. So if you have forgotten to written first one and you have shown this graph, when you have sketched this graph, you will get the mark. So this one is ln S. Now, so 3 marks for this. So we have 2 plus 4 plus 3 means 9 marks. And remaining 6 marks are for additional details and for safety consideration. So you will get 5 marks for additional details and you will get 1 mark for safety considerations. So in this case, if you have written this one, you will get 1 mark. Just keep S naught constant. Quite straightforward. Then also you need to talk about how you will keep this constant. So initially line up corner of the plate with fiduciary marker, or you can say about meter rule. You can also talk about meter rule. So you will also get 1 mark. So we just need 5 marks from this one. And also if you have mentioned about video camera, you will get 1 mark for that. View frame by frame, you will get 1 mark for this one. And measure B, magnetic flux density, using Hall probe calibrated, you will get 1 mark. And also you have to mention adjust probe until maximum value is obtained. So you can also talk about magnetic field perpendicular to the area of the sheet. So you can also mention about horseshoe magnet. You can talk about pair of magnets. 1 mark for that part. But you only need 5 marks from here. And repeat measurements of T in different positions. 1 mark for this one as well. And that this mark is very important. Repeat experiment for each value of independent variable and take average of dependent variable. So this mark is very important. You can mention this one in any experiment. And so you just need 5 marks from here. So this one has 1 mark. This one has 1 mark. You just need only 5 marks from here. So this is what mark scheme is expecting for the answer of this question. Now, if we go to the next one. So here is the safety consideration. 1 mark for this one. You can write any one of them. We have discussed about sandbox. in case sheet falls. So this is very important. Underline. It has to be, because this is how you will protect. This is why. So how and why has to be made. Mean risk and protection. You can also talk about use gloves to protect from cuts or sharp edges. We get one. So this is how these 15 marks will be awarded to you. I hope you're quite clear about question 1. So it's time for question 2 now. So we will just go directly to question 2. For question number 2, it is very important that you understand this question. Means you read this question carefully. At least you need to understand what these quantities are representing. Because I have seen many students, when they read question 2, they will just try to write down this equation in linear form, and then they try to write down the gradient and y-intercept. But understanding of this question is important. Means you need to understand what these quantities are representing to answer remaining parts of the question. For example, for this question, you need to understand what z is representing, what y is representing, what rho is representing, L, R, and T. So in this case, y and z, they are representing resistance. L is the length of the wire, and D is the diameter of the wire. Rho is the resistivity of the metal, and R is the resistance. So these things we need to understand. If we have understanding of these things, then next part we will go to part A. For part A, we need to sketch a graph between L. L has to be on the y-axis and 1 over R on x-axis. So simply we need to make L the subject, and we can write down the answer for this question. So let me quickly show you the answers. I have already written these answers, so we can go through this second question quickly. So I have made this L the subject, and 1 over R has to be on one side. So this is representing gradient, means y is equal to mx. So this is over gradient. So this is what you need to write down for this part of the question. Now let's go to the second part. For part B. For part B, it is given to us that values of R and L are given in table 2.1. We have R, we have L. And it is also given to us that each resistance has percentage uncertainty of plus minus 5%. So we can go to next part. We need to calculate and record values of 1 over R in table 2.1, and we need to include the absolute uncertainties in 1 over R. So this is pretty straightforward. So simply you have R, so you can do 1 over R, and you can write down the value here. So if we do 1 over R, simply we will get, in this case, that will be equal to 45.5. Now we need to understand how to write down the absolute uncertainty. So in this case, simply you can say x is equal to 1 over R. So just say let x is equal to 1 over R. And so from here we can write down x also, you can say, is equal to R to the power of minus 1. So if we write down the percentage uncertainty in x, we can say this is delta x by x. So here we will get, this is minus 1, means the power 1 in front of this, and here you will have, this is delta R by R. So this is the fractional uncertainty. But if we convert this one into percentage uncertainty, we have to multiply this one with 100. Minus doesn't matter, because absolute uncertainty never be negative. It has to be positive. Means the absolute uncertainty always positive. Percentage uncertainty always positive. So this negative sign simply you can ignore. So we can say this is delta R by R. And from here you can see that percentage uncertainty in 1 over R is the same as percentage uncertainty in R. So we can say percentage uncertainty in R is equal to percentage uncertainty in 1 over R. So this is the point you need to understand. And so it simply means that you have to take 5% of this value, 5%. So in this case, we will be writing delta 1 over R. This is equal to 5%, means 0.05 of this value. So we have 45.5. If we solve this one, you will get 2.275. You will get this one. But we can write down our answer up to SF only. The reason is that if you go to the graph, you can see the scale. If you go to the next one, you can see the scale. So here, you can look at the graph now here. If you look at the graph, on x-axis, we have 15 and this is 20. So one small square on x-axis, you can see 20 minus 15, 5 divided by 10 is 0.5. So this is up to 1 dB. So it's better we use 1 1 dp. 1 dp. So it will be easy for you to sketch the graph. So always consider number of decimal places means one small square and number of decimal places, because this will help you to sketch a proper graph in a proper way. Now if we go back now, you can see here. So let me make this one a bit smaller so you can see this. So in this case, this is how I have written all these answers. So you can see this one has 1 dp, so also we are using 1 dp here. So this is 1b here. This one has 2sf, so you can use 2sf here, or you can use 3sf. So all of them, they have 2sf. So here we can use 3sf, and these uncertainties, absolute uncertainties, we can use 1 dp here, 1 dp. So you see they have the same number of dp. So this is the point you need to understand. They should have same number of dp. So same number of dp. So same number of dp, not same number of sf. So if you write on this one, you will get the marks for this question. Now let's move on to the next part. For the next part, you need to understand the graph. Then we will come back to the gradient. For this question, you can see I have already drawn this graph. Maybe not very good looking, but at least you can get the idea for this graph. So let me show you the better picture of this. So these lines you have to draw. So you can see this one is the best fit line, means the red one is representing best fit line, and the yellow one, this is representing LOWF, worst fit line. Best fit line has to fit all the points, and worst fit line, it has to pass through all the error bars. You can draw the shallowest one, or you can draw the steepest one. And also in the exam, you have to draw the triangle. So this is the triangle you have to draw. So let me use here. So the triangle you also need to draw. So in this case, I have drawn this one triangle for best fit line, and also have drawn one triangle for worst fit line. So this is another triangle, this one. So these two triangles are simple. You can draw one triangle. For example, how you will draw one triangle, you can just consider this one, because this is crossing best fit line and worst fit line. So simply you can draw one triangle. That will be quite enough for this question. So this is how you need to draw this graph, and these points you have to consider. So if you follow this one, you can get good marks. So it means you can get full marks for this one. And also it is important, you can write down the coordinates. For example, I have written coordinates for this point here, and I have written coordinates for this point here, for this point, because we have drawn this line, and for the coordinates of this point I have written here. So these are coordinates for worst fit line, these are coordinates for best fit line, and we can use them to calculate the gradient. And also at this point you can write down the coordinate for worst fit line, and also you can write down the coordinate for best fit line. So this will help you to find the gradient. Now if we go back, so let me show you how I have calculated gradient. So this is how I have calculated this gradient. So in this case, you can see the gradient of best fit line. I have taken these coordinates. You can go to the graph, you can see. And so unit is important, because unit for L is centimeters. So this is centimeters. So you can calculate best fit line, worst fit line, absolute uncertainty. That is the difference between these two gradients. Difference. So also it has to be always positive. So you can write down your answer in this form, or you can write down your answer in this form. So they have the same number of dp, so you can write down in this form, or you can write down in this form. So this is acceptable. Now let's go to the next part of the question. So here is the next one. For this part, simply question is asking you to calculate average diameter and include absolute uncertainty. So average diameter, simply you can take average. Absolute uncertainty means maximum value minus minimum divided by 2. Mean this is half range method you can use. So in this case, this is the answer. So same number of dp here, same number of dp here, and the unit of this one is millimeter, because they are given in millimeters. So this is how you can answer partly. For this part question is, it is given to you resistors Y and Z each have a resistance of 22 ohms with percentage uncertainty of 5%. Use the answers to A, C3 and D and determine the value of resistivity. Include an appropriate unit resistivity. So in this case, most of the time you have to go back. Part A means the equation that was given to you in part A, that is very important. So you have to go back to that one, and also you have to look at part C theory in this case and D, because these are the hints. You have to use them, so that will make your life easier. So let me show you the answer how we have done for this part. For this part, you can see gradient in part A. We have found gradient was equal to this. So we can make E the subject. So this is equal to this one. And all the values are given to us, because in this case, this is the resistance. We have this is resistance. This is also resistance. And value of D we have just found in part E. And that was in millimeters. So the unit was millimeter. So you have to multiply with 10 to minus 3. So use those values. And here is a 4, and this is the best fit line, gradient of best fit line. We have to multiply with 10 to minus 2 because that was in centimeters. So if you do calculations, you will get this answer. So this is how you need to approach this part. Now let's move on to next one. For the next one, question is asking you to calculate percentage uncertainty in rho. And the equation for the rho we have already discussed. And so rho is equal to this. Rho is equal to this one. So this is constant. This is constant. So when quantities are multiplied and divided, we don't take this coefficient in calculations of percentage uncertainty because they will be cancelled. So that's the reason we don't consider percentage uncertainty in these constants. So simply in this case, we have y. So this is delta y by y, delta z by z. We have this diameter. So it has power. So power you have to multiply here. So this is delta d by d, delta gradient by gradient. And this has to be the gradient of best fit line. So if we plug in numbers, we do calculations, we will get this answer. So this is how you need to approach this part of the problem. So if you have any questions about these things, you can leave your questions in comments. So this is the main idea, how you need to approach. And if you do calculations by yourself, your answer will not be 21.7% exactly, but your answer has to be close to this answer. So let's move on to next part. For the next part, question is you need to determine the resistance that would give a value of L that is equal to this one. Determine resistance of R that would give a value of L of 95.0 centimeters. And also we need to include the absolute uncertainty in your answer. And so for this purpose, again, we have to go back to part A. In part A, most of the time you have to go back to the basic equation, and from that you can find the value of resistance or any other quantity they ask you to calculate in the exam. So in this case, we have to calculate value of R if L is equal to this. So we will go back to the basic equation. This is the basic equation. R is equal to this one. And in this case, we can calculate value of R because we have all these quantities. So this is value of R we have calculated. Now we need to calculate the percentage uncertainty in R. Absolute uncertainty of R means delta R. So this is how you can write down delta R. So you have to multiply by R. And this is value of delta R. And this is how you can write down R plus minus delta R. So the final answer is 21.5 plus minus 7.3, and this is in ohms. But one thing I haven't explained to you yet, let me go back. The unit question was asking you include an appropriate unit. So let me explain you a little bit about this part because I didn't explain this part. For this one, you need to understand one way to find this one is what is the unit of this one, what is the unit of this, and what is the unit of this, and what is the unit of gradient, means we are talking about this one, rho you have on it. So the unit of, in this case, y, that is ohm, unit of z, that is also ohm, unit of diameter we are using is meter square. And what is unit of gradient? Unit of gradient is ohm meter. So you can find out from here, ohm cancel, meter cancel, you can find out ohm meter from here from the equation. But the smart way is that resistivity, if you remember, if the quantity is resistivity, it means the unit of resistivity will be ohm meter. You can derive if there is any unknown quantity. If there is known quantity, simply directly you can write down the unit of that quantity. I hope this paper will help you to understand paper 5, and also I hope you have better understanding of paper 5. If you have any questions, please leave your questions in the comments and I will try to answer as soon as possible. See you in next video.